Okay, so I guess we should get started. Hi everyone, I'm Alex King, and a couple of guys from the DevOps team at GoGo. Very excited to be here and start talking about some of the things that we've been doing. But before we get into that, we should probably cover some of the things that are not covered in this presentation. So we're not going to talk about how we got started. You've probably heard that story from other places, but if you are looking at doing this stuff and you haven't yet, then Kenzan were an enormous resource for us. We're not going to give a complete overview of all the things in our infrastructure. You can figure that out. And we're not going to talk about how we deploy Spinnaker, but we use Spinnaker. But the things we are going to talk about is that primarily around the tooling that we've used to extend Spinnaker called Foremast and how we do deployments for interesting and innovative ways. But before we get into that, I'll just do a quick overview. So as far as Spinnaker at GoGo goes, this is, you've probably all seen this slide, but this is really where we were 2 years ago. And to some lesser extent, we still are in this space a little bit with our legacy data center, but we're getting a lot better. So just to talk some more details about this, hopefully you guys could read that. Yeah, so we had just monolithic applications in the data center, days to weeks to deploy. We didn't really have any good consistent testing methodology, and everything was just so slow and unreliable. Probably one of the gating factors in amongst all the other silos that we had was the change control board met twice a week. So developers would realize it would take a lot of effort to get things changed, and so they'd stack up a bunch of different changes to go into one big deployment push, and that in turn would have consequences in terms of how effectively we could deploy in a reliable way. So compare that with now, lots of small Spring Boot, Spring Cloud microservices, although within the DevOps team we tend to use Python for most of our stuff. It's super fast. Like we can get typically we measure deployments in minutes. We do that because we pretty much force developers to use Spinnaker. They're not allowed to deploy any other way. And of course, there aren't any manual scripts or handwritten notes that the deployment processes go through. It's all handled through the repo. And of course, we had a second data center where we did failover every month or so, but it's not the same as having multi-AZ and multi-regions like we get with AWS. So we think that's cool. This is kind of an overview of where we were when we started, specifically with regard to Spinnaker. So we met in the summer of 2015. Weren't really sure what we were going to do, but we thought Asgard would be great. So we got Asgard up and running, and then within a couple of months of that, we actually got some developers on board, and they were pretty enthusiastic because they don't like the idea of taking days to weeks to deploy either for some reason, which is weird, right? And then Spinnaker came out, and we just cut over to that as fast as we could. And one of the things that's part of Asgard was something called PyAsgard, which was an API that we put together to make actually accessing Asgard and deploying through Asgard a lot easier, which took a lot of reverse engineering. And then when we brought Spinnaker up, we had to do an equivalent for that. And so that's where Foremast came along. We open source Foremast. Everything that we do is in the open source version, and you should go and try it out. We think it's really cool. And then we sort of built on our momentum. So we put Lambda support in there. We data pipeline, S3, and so forth. Then probably, in theory, by the end of this year, we should have everything out of the data center, and we can start talking about containers and stuff. So this is just an idea of where we are, and this is just an amazing slide, and it seems to just get better every month. But the orange line is how many Spinnaker deployments that we're doing to production, and the blue line is how many deployments we're doing to the data center. And so we saw a slight increase as we were slicing those monolithic services up into pieces. And allowing us to pull bits out of the data center, but that's, I think, on its terminal decline now. The other thing that's really interesting about this is those two low night lines that you can't see very well are how many outages we have due to deployments. And I think for Spinnaker, we've had maybe 4 in the history of forever over the last more than a year, whereas typically for the data center, we were seeing 2 or 3 on average a month for the longest time. I talked about production deployments. This is for the month of July, I think it was. This is our total deployments. So we're getting pretty close to peaking about 250 a day. And Jenkins seems to handle that pretty well. And for most of the time, the stuff's pretty reliable. Here are some other bigger numbers. So about 634 developers, 270 pipelines, about 3,500 deploys a month, which I think works out to be about 1/20th of what Netflix has, maybe slightly less than that. And given how small we are, we're pretty proud of that. And the last couple are pretty fun. So we've got about 950 EC2 instances, but also 4 which are not managed through Spinnaker. And probably over the next couple of months, we'll be able to get the total number of manually deployed EC2 instances down to 0, which I think is really awesome. So just to wrap up this section, our philosophy is driving towards DevOps. So that means for us that developers run all their own stuff, that they do their own deployments, they look after their own metrics, they do all the operations that they need. And so as we're driving towards DevOps, we're driving also towards NoOps, which means that we don't have an operations team. In order to be successful at that, we've been very aware that operations has to be easy for developers. So we want to make sure that we minimize the cognitive load on developers when they do their operational stuff. So we have to make it super, super easy for them. So to do that, we've brought on tooling initially like BASGALL, and then later Foremast to deliver configuration as code. The idea behind that is you have one repo that has your application in. It's got all the code for how to build the application and also how to deploy through different environments. So with that, I'll hand over to Doug to start talking about Foremast.
Hi, I'm a DevOps engineer on the team. So Foremast, I mentioned Foremast during the panel, if you were there. Foremast is the backbone of our tooling for Spinnaker. It's how we use Spinnaker. Everything we do through Spinnaker kind of goes through Foremast. And I'll go into like how Foremast works and how we use it. So Foremast is basically, it's a few different things. First is pipelines as code. It's similar to the declarative pipelines. You know, you get consistent, repeatable, source-controlled pipelines. We did Foremast when we first started Spinnaker because this was a really hard requirement for us. And declarative pipelines were a while out. But Foremast does a bit more than that as well. Foremast handles all of our AWS infrastructure for us. So if it can create things through Spinnaker, it uses Spinnaker. So things like load balancer and security groups, it just calls out to Spinnaker and creates those. But it also handles a lot of resources for us that Spinnaker doesn't handle, like IAM policies, S3 buckets, plus a bunch of other bigger things like Lambda and AWS data pipelines. And it enables us to use these consistent, repeatable pipelines that we've established for the company while applying it to other resources outside of Spinnaker, like Lambda, which is really big for our developers. It also helps us enforce naming conventions. Naming conventions are really important for the organization for things like auditing and cost management and budgeting and stuff like that. So through Spinnaker or through Foremast, we have a really customizable format section of our config that allows you to define naming conventions for any possible resource that gets managed so that we can enforce this consistency across the whole organization. It's open source. We open sourced it maybe 1.5 years ago, and that's been super fun, so feel free to check it out. Why we created Foremast, we have 270 some unique applications. It's growing all the time. And we thought it'd be unreasonable to expect our developers to create all these pipelines by hand, especially with the level of consistency we wanted. A typo in your security group's name, and suddenly it's not going to be applied properly, and things like that. We also had some auditing requirements that had to have been included. And each pipeline, 90% of our apps are 90% the same. They're all Java, Spring Boot apps running behind Tomcat, but there's all these unique little needs that they need. So we wanted to provide a very consistent pipeline while allowing for the uniqueness of each of these applications. We also needed to be able to generate AWS infrastructure prior to the deployments. This was important to us because we wanted the infrastructure to be almost as dynamic as the deployments. We didn't want just to create an ELB and say, now you're using this. We wanted the developers to have control over their health checks and their ports and all these things on the ELB and make sure that's generated before every deployment so that you get your defined settings without needing to come to us or coming to an ops team to do anything. And then our audit and compliance, we had things like all pipeline changes go through Foremast for us. No developer has the ability to change a pipeline UI, and this way we can guarantee to our auditors that all of our checks are still in there. No one can delete the audit checks because they simply have to go through our tool. So how Foremast works. Foremast looks for a few JSON configs. We bundle these configs directly with the application. So the application developers have control over these configs. The first one's a pipeline.json. This configures pipeline-wide settings. Like, is Chaos Monkey enabled? What accounts are you going to deploy to? Who owns it? Notification settings, stuff like that. And then there's this application master environment.json. And you have one of these for every account or environment that you deploy to. And it sets account-specific settings, things like instance counts and sizing, load balancer ports, security groups, a whole bunch of things. And so the developers have really full control over their infrastructure at this point. We set a lot of same defaults, so they can be pretty small configs, but they also have the ability to really do what they need for their apps without ever talking to us, hopefully. So Foremast takes these configs and it renders a bunch of Agenda 2 templates. These Agenda 2 templates are highly customizable. Foremast ships with some base templates, but at GoGo we use our own internal templates so that we can inject GoGo specific logic into some of our pipelines and set the consistency we want. So it renders these templates, post up to Spinnaker, and you get your pipeline. At GoGo, we trigger this all off a pre-receive GET hook. So every application in GET has this hook, and when they make any change to these JSON configs, when we push, before accepting the push, we're going to run Foremast and we're going to generate the pipeline. If that generation fails for any reason, we can reject the push. And what's ever in GET at this point is the source of truth for what the pipeline should look like. And it supports X509 for gate authentication. We use SAML on our front end, but Spinnaker and Foremast doesn't really care about that because it's hitting the API. Okay, so some examples of our configs. This is the pipeline.json. It's the smaller of the configs. It can definitely look smaller than this. Like we said, we set a lot of same defaults. And if they don't provide some of these things, that's okay. We'll use our defaults. So this is where they set things like what base image to use, how big your root volume size should be, is Chaos Monkey enabled, and what environment should have exceptions, notification settings, stuff like that. Pipeline-wide, application-wide settings. Sorry, this is going to go well. So this is the application master environment JSON, one for each environment you deploy to. And this is bigger. Again, we set lots of same defaults, but there's way more settings than there are even on this slide. But you can see things in this one where they can set health check types, grace periods, instance sizing, instance counts, scaling policies, open ports, health checks, whole bunch of things. This is also where things like Lambda trigger settings would go, which we'll go over later. This really gives the developers as much control as they want over their apps. While allowing us to set same defaults, which is the important part. I don't feel like the developers need to think about their health check grace periods. Just like a new developer, we can set a same default. They don't really have to concern themselves with it until suddenly they do. And our developers seem to find that pretty powerful. I like it. So then those are the configs that the developers control. But then there's our templates. And our templates define how the pipeline is actually structured. And then we use Jinja 2. It's all written in Python. And Foremast really only cares about a couple of these templates. It cares that, on the left is the wrapper template. This is what Foremast cares about. And it just is a bunch of include statements and a bit of logic to what other templates to include to build out your pipeline. So in this example, you can see some GoGo. This is where we inject GoGo specific logic so we can keep it out of the open source stuff. So things like at the bottom, there's an if data.app pipeline dashboard, which would come out of your application.json config, the app master environment.json config, include this stage. And those stages then are broken up into smaller digestible chunks there on the right. That's just a Jenkins stage that's used for auditing stuff. And we fill all that in with the settings from your pipelines, but breaking them down like this with these includes allow us to have a lot of reusable staged chunks. We have a bunch of different pipeline types we support within the organization, but things like audit approval have to always be the same. So we can just include this stage into any of them with this wrapper, and so we know we get consistency across it. You also can just use the raw pipeline JSON. Like that stage is just me going into the UI saying view as JSON and then copying out that stage chunk and filling it with some Jinja stuff. But if you don't even want to use the templating, you can just put the raw pipeline JSON and now you at least have a reproducible pipeline. So that's Foremast, but some lessons we learned along the way, especially around open sourcing, was we wish we had started developing it with open source in mind. Like when we first started, we were under a time crunch. We just wanted to get something that we could use. But we realized a lot of people were facing similar issues, and we decided later on we wanted to open source it. Scrubbing the commits of all of our sensitive data and stuff we didn't want to expose to the public, that was a pain. That took us days to go through all of our commits. Abstracting out company logic like the templates, that was a pain and took a long time. If we just started saying, this is awesome, we're going to want to open source this, and we started with that in mind, I think we would have saved ourselves quite a bit of time and maybe ended up with even a better product. Try to build it in a core Spinnaker first. I think we all wish we would have engaged with the Spinnaker community earlier on with this, so maybe it could be part of core Spinnaker, or at least get their feedback on what we're doing. We initially going to do this for one time constraint. Just none of us knew Groovy and Spring, and we were all new to it, and we just needed something. But it would have been neat to maybe try to build it into core Spinnaker a bit better. No internal forks. We've been really hard about this, and it's been really great. We run the latest tag of Foremast. We downloaded it from PyPI. We have absolutely no internal fork of it, and I think that helps keep the open source code really clean. It makes it so everything we have to really think about, and that no hacky features get in because we don't want to admit to the public we do hacky features. And even without a large user base, open source has been awesome. I think there's a couple organizations that use Foremast outside of us, but even if no one did, it's still been an awesome practice and it's made our code better. Everything we now do is public, and I think all the developers keep that in mind, and we end up having more thorough code reviews, better commits. We think about the changes we are going to put in as though they're going to affect a large set of people, and that makes it all better. So that's that's Foremast. Now I'm going to pass it off to Steve, and I'll talk about how we utilize Foremast and other things to do Lambda deployments.
So my name's Steve BASGALL. I'm a DevOps engineer at GoGo. I had a big part, the whole team worked on Lambda, but I had a big part of it myself. When we adopted AWS at GoGo, we had never really used it manually, or we never used a delivery model other than kind of the Netflix cloud-based microservices delivery model. So we didn't have a set of developers who were already used to deploying Lambda functions manually and configuring them through the UI and everything like that. When we introduced AWS to our organization, it was through Asgard, through Spinnaker, through some of the tooling where everything they do is based off a Git commit. And we wanted to provide the same experience for those developers with Lambda functions. The first Lambda functions that we supported in the organization, the configuration was done by hand by the DevOps team in the UI. And we had some scripts in Jenkins that would upload the artifacts so developers could do their own promotion. It became obvious that wasn't going to scale very well as more and more people got excited about deploying Lambda functions. So we had to come up with another solution. So at that time, Lambda support was on the roadmap for Spinnaker. And we had to decide as an organization if we wanted to wait for Spinnaker to incorporate it or if we wanted to take a stab at it ourselves. So initially, we decided as a team to at least do some basic support and maybe not invest completely in it, but see where things lie after a little bit. In hindsight, for once, I feel like we made the right decision. I don't know what the status is of Lambda with Spinnaker, but I don't see it on the roadmap too much anymore. And some of the things we learned along the way are probably reasons why. I think that Titus probably meets Netflix's requirement for kind of serverless applications that are triggered. in some ways, and seeing as how they're the main developer of Spinnaker support for AWS. I don't see any other companies necessarily adding that. So we had a few goals starting out. It was to present our developers with a consistent interface, not just for viewing where their Lambda deployments are at as far as like versions and environments and things like that, but also a consistent configuration interface as far as the JSON files that we use to configure our deployments for EC2. So we wanted to make it seamless. We wanted to build on the knowledge they had already gained as far as deploying through EC2 in Foremast and make it a really simple process for them. So our team at this point, we had created a few Lambda functions ourselves. The DevOps team obviously has some Lambda infrastructure for just to support our work. So we knew a little bit about Lambda, but we were probably only about a month ahead of the developers at this point. It led us to thinking that Lambda configuration must be simple, right? It's just a zip or a jar file, which is a zip file, and some basic settings like the function entry point for your Lambda, the runtime, whether it's Java or Node or Python, etc., an IAM role, and then memory and timeout settings, and that's all there is, right? Well, realized as we went on, there's a few more options to support. They can be VPC aware, which means the Lambda runs internally in your VPC instead of as a public execution. Luckily, and through no fault of our own, we were able to reuse most of this networking stuff from the EC2 part of Foremast. So it wasn't a huge deal. We were just kind of applying it to a different resource. And I don't remember what the first trigger type we started off with was, but we were like, these triggers seem to follow the same pattern. There's 8 triggers, what's the big deal? This is probably where we ran into the most trouble. The policies for the Lambda policies are kind of separate from IAM, and they define like what you can trigger, what your Lambda function has access to be triggered from. They're kind of internal in this one string that's hard to manipulate, and they have their own statement IDs in there, and you can't work with policies individually. You need to work with the whole set of policies at once. So we definitely had some learning to do there. At least on the Lambda side, it's pretty consistent as far as how you need to manipulate those and how you need to configure the Lambda functions to be triggered by these external resources. But then on the external resource side, it's completely different. Every single trigger has a completely different configuration on the S3 side or on the SNS side. And we were surprised to find that, to say the least. So we don't support every trigger type. I'll get to the list in a minute. So that was a big stumbling block too. It made us reduce the scope of the triggers we were going to support to just what the business needed at the moment, and then we add them as needed going forward. The last part is it's a moving target. It's a constantly evolving AWS service with new triggers being added, new runtimes being added, and new features being added. An example of that is when they had Python 3.5 support. Luckily, on the Lambda configuration side, there's just a string. You just send a different string. So there wasn't too much work needed to support that in Foremast, but then on the build side, we had to do some things to prepare artifacts for those new runtimes. Other examples of new features that came out were, since we created this tooling for Foremast, environment variables were supported by Lambda, which is a great and powerful feature. Luckily, that wasn't too hard to add. We added it right away, and we got a lot of benefit from that. As new triggers come out too, we evaluate them as an organization if we want to add those, if there's going to be a use case for those. So this is an example. Doug talked earlier about the pipeline JSON. This is the things that are consistent for your Lambda function across all the environments you deploy to. So you have some things in here like the handler. The function entry point is always going to be the same. The runtime is always going to be the same, whether it's VPC aware or not. These are kind of global settings for your Lambda function. the IAM role, things like that. So this is going to be across all environments, things that are the same. The application master, there's dev, stage, prod. This is going to have here things that vary between environments. So in dev or stage, you may want a different timeout or a different memory size for your function. And triggers, you may think that, yes, you're going to have the same trigger type across all environments, most likely. Whether it's an S3, like put object trigger and your function triggers off that. However, the bucket is probably going to be different if you're in dev or stage or prod. So that's why the trigger type is in the environment specific configuration and not the global configuration. We also support, you see that triggers is a list there. So we support different types of triggers. Some functions, for example, with CloudWatch event, you can pass in JSON to the Lambda function. So you could have two triggers on two different timers passing in things to do two different things with one function. The trigger types we support are S3, CloudWatch events, which is like a cron-like trigger. CloudWatch logs, which is based on a log group being written to and doing something with that. SNS and API gateway. For all of these, for S3 and SNS and CloudWatch logs, we assume that resource already exists. Someone's made an S3 bucket from some other application and then or some other purpose, and your Lambda function is just triggering off that. Same thing for SNS. Say your application has the overall application has a topic somewhere, and this Lambda function is part of that, and so it just points to an existing SNS. For CloudWatch events and API gateway, we actually create and manage that triggering resource through Foremast as well. So it allows you to configure. For CloudWatch events, it's things like your cron definition, how often it repeats. For API gateway, we had to make, it's such a big target, it's such a big trigger, and there's so many different ways to use it. We had to make some assumptions about how people are going to use API gateway, because that's a whole huge configuration item itself. API gateway is massive. So here you can see what the basic pipeline looks like. There's two stages. There's an infrastructure setup stage and then a deploy stage. This pipeline deploys only to the build account. It's a Spinnaker health check. It's something the DevOps team uses. We're also one of the biggest customers of Lambda support in Foremast, so it's made our life a lot easier when you have to deploy a function to 8 different accounts, 2 different regions. You can just kind of do it through Spinnaker and click and you don't have to manually run some job or copy and paste or anything like that. It's worth noting the cluster view does not work. There's no clusters, but if you look at the pipeline execution history, you can see what version is in what account. The first step here, it creates or updates any IAM role needed. It creates or updates security groups. If it's VPC aware, associates them with the function. It creates the Lambda function itself on the first deployment, and then it creates or updates any triggers defined. So you could change triggers, and Foremast would wipe out all the old ones and put the new ones in if there's changes. The second here actually uploads the application artifact. In this case, it's always a zip file. Lambda supports jar files too, but they're just zip files. There's not much difference there. Sets the function configuration like memory, timeout, entry point, runtime, role, whether it's VCP aware, environment variables, things like that. It's a little different than it's not an atomic deployment. So the way we do it is in these 2 steps. Something could go wrong, and it's not quite like EC2 where there's a nice health check and nothing happens until that health check is complete, and the new cluster goes into service. With Lambda, it's a little more, you're just kind of shooting a gun. That's the way it's implemented now. You could use Lambda qualifiers to actually kind of prepare deployment and verify that in a number of different ways before you flip the switch. And that would ensure there's never like a half deployed or something goes wrong halfway through. If that is enabled, it's something I'd like to do. It'll make it work a lot better, and you'll have more confidence in it. So That's all I've got for Lambda. I'll be happy to take your questions at the end, but Joel here is going to talk about how we use Foremast to deploy static content with S3.
Yeah, hey guys, thanks Steve. So we had an interesting use case for static deployments of S3. So this says static content, but we've actually realized it's really powerful that you can actually use it to deploy just generic files. So touching on that, why did we add this support? So the first thing we wanted to solve is that there was a huge problem of inconsistent and unreliable S3 uploads. Such that some team used their local laptop, and some team used Jenkins, and some team uses Raspberry Pi, and it's just all over the place. So we wanted to solve that because at the end of the day, we saw a fundamental problem that there was this S3 guru on every team, right, trying to figure out how to do the pipeline deploys. We wanted to solve the issue of repeatable pipeline S3 deployments. So instead of solving the issue of how you get to the packaged artifact that gets deployed, we wanted to solve the problem of getting that packaged project out to the world. The next thing is ultimately it was really visualizing these deployment flows. Again, earlier on I mentioned that people are using their laptops. It causes a fundamental problem of not knowing what just got released unless you're that engineer who pushed that code and somehow blasted your team on Slack or email, whatever you did. So we wanted, Spinnaker does a really nice job of visualizing deployment flows. The next thing is a little bit into, we wanted to prepare for the future. We're going to be eventually leveraging a CDN for our content distribution. So it's much easier when you deploy in a consistent fashion, especially in patterns of your UI or your static assets. It makes writing a lot of the rewrite rules and everything you need to do to serve up that cache much easier. Every team can kind of pivot it a little bit better. We wanted to add basic canary support, and we'll touch onto that to show how we kind of leverage it at GoGo. I think the best thing is version controlling the S3 infrastructure and policy changes. As we all know, S3 has caused some issues in the past in terms of being public or having more lockdown or more open policies. So by doing this, you can actually define your entire infrastructure for S3 in a pipeline step, and also all the policy associated to it. And then finally, batteries included from Spinnaker and Foremast. To add support to it wasn't much work. Why are we going to help rewrite a whole UI around this? Why are we going to? We already have a deployment infrastructure. Let's just leverage it. So just to kind of run through real fast, I didn't want to touch on this too much, but in terms of production packaging, in terms of getting that deployable artifact for our UI team specifically here, is that we have UI developers. They focus on just writing node packages. They write them up, either they go public or private, whatever needs to go to their NPM registry. At the end of it, those various packages that they write, those components, web components, get pulled together and ultimately create this release package. The whole kit and caboodle, everything that you want to see, that the world wants to see. At GoGo, we look for tar-gz. I mean, you can change that to whatever you need it to be. So Foremast looks for these compressed artifacts, or these artifacts in general, at a specific path, which is configurable. You can say go to the dist folder, go to the dist app web folder, whatever you need it to do. And then the release packages are then taken from that folder that you just configured and placed into the S3 bucket path at a static path. Again, we do tar-gz, so we have to uncompress it to actually service the world so people can actually see those wonderful JavaScript files. To just kind of go and show the deployment pipeline, here's how it kind of looks. Just a basic pipeline. We have a checkpoint step at the beginning, which does audit approval, which we'll talk about later. Assume that all looks good. We go into the infrastructure step where your S3 bucket is provisioned. Let's say this is the first time you're running through it. It'll create a new S3 bucket. The next thing it'll do is it'll apply that S3 policy, whatever you put in your repository. It'll create a DNS record if it's website enabled. It's not necessarily what may be out there, but it'll be something that's similar to the rest of the pipeline DNS records that we create. And it'll create it at a specific path. So, for example, this is build 1. It'll put build 1. It'll put all your static assets. You have an index file, some bundle file, right? The next step is actually deploying to Canary. So we take that code and put it into a Canary label. And we'll touch on that. Is that we didn't want to really have an opinionated way of doing UI deployments, but our UIs and our Canary releases are a little bit weird. Most people can Canary and just say, hey, send 25%. The problem is our space, we do aircraft. So aircraft isn't always constant. Some aircraft may be pulled out of rotation for 2 weeks. So our Canaries can be very inconsistent. So by doing this, we can have a pretty static way of then configuring some backend load balancer, whether you use like HA proxy, Nginx, CLB, NLB, whatever, and you just route it. So basically, you are basically in control of how you want to route to this Canary folder. So at this point, we're basically monitoring it, saying, hey, this things look good. Yeah, okay, we're seeing that our traffic looks good. And you finally get to the next Canary, the next step and the next checkpoint where you say, let's get this out to the world. I want people to see this. And then that's all it is copying that Canary folder over to latest. And then finally, the last thing we do is we test, we alert, and we tag all the things. So we have a pretty heavy tag strategy such that we tag everything back to a Git commit. We test, this is an integration test after the fact, but you can interject it anywhere in the pipeline. And then ultimately, we alert to audit stuff and whatever, Slack, whatever, saying, hey, your pipeline is done. It's out in the world. I'm not going to touch too much of this because Steve and Doug already kind of covered it. But if you look at this, it's almost exactly the same pipeline. All you did is just change the S3, the type to S3, and you pretty much have S3 access. Woohoo! Now this is where things get a little bit interesting because per environment, you may have different configurations for your S3 bucket. Maybe your dev bucket isn't wide open to the world, but your production bucket is. So things like the path that to start serving from, the bucket ACL, the bucket policy. The nice thing about the bucket policy is that this is just literally the JSON that's spit out from the policy generator from Amazon. You can do the website enabled flags. You say, hey, make this website enabled. The one thing I wanted to touch on that is not very explicit is that the shared bucket master true. And what that means is that it's not uncommon for teams to have a bare repository that's just their Spinnaker, their S3 infrastructure. And by doing this, teams can have a shared bucket master, so you can deploy multiple UI assets to a single bucket. At first, this was nice because teams didn't have to maintain multiple buckets. Our service limits were really good because before we had one bucket per every little microservice and little app. But by this, it kind of a little bit of a side thing is that you could actually hand this off to a security team and ops team. I heard that a lot of people put the security team in charge of the S3 buckets. So here they can maintain that. We don't, the developers own it at GoGo, but that was an unintended side effect that we didn't really realize until we got here. So how does it look for the other apps that aren't maintaining the S3 bucket? It's just this. Say where you want to deploy to, you're done. It'll put it in there, it'll put it at the path, and it'll service it up. Much easy, it's like 12 lines, so you could probably make it even shorter. And with that being said, I'm going to pass it over back to Doug so he can talk about those auditing steps.
Yeah, this is the last thing we'll talk about, and it's how we handle our auditing and compliance. It's been a big part of Spinnaker for us, and I begrudgingly had to talk to a lot of auditors. So here are some of the requirements we had. At GoGo, we're SOX and PCI compliance. I'm sure most of you follow similar ones, even much stricter ones. Luckily, I don't have to deal with the FAA or anything like that. That falls on other organizations. But yeah, so for SOX, some of the major things we've come across is, one, we needed searchable records of each deployment. We needed to validate that a single developer cannot make a change and deploy that change to a prod or one of our compliance environments. Members outside the application group, Bob and HR, cannot deploy an app to a compliance account. No manual changes. So this was a big one we went back and forth with our auditors on, is that they were concerned developers could go in and just remove the compliance stuff from the pipeline. So that's a big reason we have Foremast. All pipelines are locked in the UI. All pipeline changes have to go through Foremast. And from the team, one of our requirements was we just wanted to maintain our speed. We didn't want another change board, which auditors kept asking for. We didn't want to make any compromises, really, to get this. So here's a couple ways we've solved some of these problems. So recording all deployments. We actually do this two ways. The first way we implemented was ServiceNow. It's a ticketing system. It matches our old legacy change board process, except at the end of any production pipeline, we create a ticket automatically. This matches legacy process. It doesn't slow anything down. It's transparent to developers. No one really cares. We just create a ticket, and some people that look at them somewhere are happy. The other way we record them, which I think is a much better way, is what we call Audit DB. But essentially, we use Echo webhooks, which if you haven't seen that feature, Echo, you can point to an endpoint, and it'll send a whole bunch of pipeline information to that endpoint, like every executing stage, the status of it, pipeline context, stuff like that. It'll send to this endpoint. So we send it to this app we wrote. The app parses out important information from a deployment perspective and writes into a database. It also stores the entire pipeline execution. So that way, if auditors come back and say, I see this app was deployed to prod this date, what happened? I can say, here's the entire pipeline. Here's everything that happened to the pipeline. And so this works really well. So we can look up all deployments, and we can use it to generate metrics, and we can use it to generate reports for auditors, and we just have a full history of everything that's happened on these. There's a little snippet of our code, or a little snippet of the database that shows like this app was deployed to this environment, who had this approver with this git commit, and gives us good reports. And the other big one was 2 developers per change. The SOX always required that the person that made a change cannot be the same person that deployed the change to prod. And so we handle this through a combination of a manual judgment stage and an auditing stage. The auditing stage is really just a Jenkins job. So the person who clicks the continue button in our manual judgment stage cannot be the same person that made the commit that is being deployed. If it is, audit approval will fail, and it will never do infrastructure setup or deploy production. It'll just fail out. It'll also send a Slack message to the offender saying, hey, it failed for this reason. Also with an audit approval, you can enforce that like the person that clicked approve must be a master on the repository, or must have certain permission levels within GitLab is what we use. Must have certain permission levels to deploy. And that way, like maybe only the manager of each team has control over this, but there's been cases where a manager or team lead has said, I want to be the one that says you can deploy to SOX. And he can have that ability. He can be the owner of the repository, and you can lock it down so only owners can deploy to certain environments. We don't put this restriction on stage or dev at all. That's all developer driven. This is only for like our compliance environments, which we have a couple of. Auditors are happy with this. It proves 2 people are involved with the change. The biggest thing was we had to prove that the pipeline was locked down, so no one can remove audit approval. They kept bringing up like a developer can just click delete and bypass the whole thing. So it's where Foremast comes in. We lock all pipelines in the UI. All changes have to go through. So that's how we audit. Yeah, that was our talk.
So on my first slide, I said thanks to Kansan, and Dave's actually in the back there. So Dave's awesome. Thank you all very much for listening. This has been a lot of fun to do. We have to take questions now. Also, lunch is coming up, so we're happy to meet with you guys later. Joel also has a big pack of Foremast stickers just in case you're interested. And so thank you.
Yes.
Awesome stuff. I have a question regarding Foremast. Was the decision to handle the core infrastructure, like let's say security groups, that sort of stuff, was Terraform sort of brought up, and what was the deciding factor between like building your own or like plugging it in to use like Terraform or something like that?
So we do use Terraform.
Okay.
We rely on it pretty heavily. I think we thought about that at some point. You could use like a Terraform module and have it auto apply, whether it's in a Jenkins job or running in a container somewhere. But instead, we went with Moto 3. Most of the Foremast stages are run from in GoGo are run from a Jenkins job, but they could be run from anywhere really. It's kind of location agnostic.
It's also because Spinnaker supports creating a lot of these. So Spinnaker can create security groups and load balancers, and we wanted to use the Spinnaker APIs for as much as possible. At that point, we've already got the tooling around everything else that it was easy enough to make Moto 3 calls for the things that Spinnaker does for.
I just wanted to touch on one last thing, is that through the pipeline, we create an application security group, so developers are in control of their applications in terms of what comes in and what can go out of it. We do some generic Terraform for like allow VPN users, allow Office users, but if the developer does not want anyone in the office to hit it, they are in control of what apps can talk to it. We allow cross-account access as well. That was a feature that was recently released. So you can say, hey, I want this app to talk to me at port 80. And since every developer has that, it's just a matter of figuring out app names at that point. You don't have to know network topology. You don't have to know CIDR blocks. You just have to know app names.
I guess what it came down to is we were more comfortable manipulating the API directly through Boto 3 than to trying to figure out how to fit Terraform in. Whether you'd be like editing Terraform files and saving those and applying it, or using Terraform modules or something like that. This was more straightforward to us at the time. Yes?
So is it fair to say that you guys are creating some infrastructure that's longer lived outside of Foremast, and then the infrastructure that whose life cycle more closely ties with the app itself, you use Foremast? So security groups, or maybe things like IAM roles.
Yeah.
You do those because they live with the app. The rest of the infrastructure you do it another.
Yeah, we're doing like VPCs and stuff like that in Terraform. Things are definitely outside the context of an application, and that we don't want our developers to have control over.
You mentioned IAM, but again, we also created an IAM profile per app as well. So developers have access to what the app needs access to. So they can say things like, I need access to this S3 bucket, I need access to SNS. So there's a division in terms of what IAM roles we do with outside of, say, something like Terraform, and something that's more app related. So something that could change, like, hey, I'm adding a feature to talk to SNS. They have a little bit of ability to do that themselves.
And they can directly edit their own policies, so they could just.
Yeah,
It's limited. They can request access to a number of things. To get like S3 write access, the bucket has to be named in a way that matches their application. So things like that is kind of how we enforce that they can't write everywhere. When we first started, a lot of our own infrastructure, like Bastion hosts and things like that, were deployed through Terraform too. But we were jealous, like the dev teams got to just click and deploy, and we're like, trying to do all this manual stuff. So these days, we've pipelined almost all of the DevOps services as well. There's a few chicken and egg things where it's like we're reluctant to deploy it with Spinnaker, but other than that, everything goes through there, so we can just click and go get a drink and come back.
Gotcha.
Yeah. Yes.
Does it support, like, going back to the IAM policy, sort of like a blacklist? Like, because for S3 is fine, but let's say for something else, are you allowed to, like, no developer can, grant some access to whatever, to like have access to all the account within? Does it have that sort of?
Yeah, it's a limited scope. It can grant similarly named. It can grant access to similarly named resources for things like SNS, S3, S2S. What else is in that services block?
We lock down S3 by group.
Yeah, DynamoDB too.
Yeah, Dynamo. So it has to match the naming. And given, if someone controls their Git group and doesn't let other people create projects that aren't actually members of that group, there's no way they can create an application with that naming pattern then. So their buckets are safe like that. Yes?
So on the Lambda stages, just want to clarify, are those custom Orca stages?
Unfortunately, they're not. They're Jenkins stages. So we use Boto 3 to construct and manipulate the Lambda function and configuration. Webhooks wasn't a stage yet when we started this effort. Otherwise, we probably would use that. We're looking at that now. But yeah, we were a little intimidated by the Spinnaker code base in general, I would say, just contributing to such a high profile project. So we use it through a Jenkins stage. It could be anywhere that Python script can run, right, is really where that can be run from. So yeah, it's kind of like a backdoor to Lambda support in Spinnaker.
Thank you.
Yep.
Now that Spinnaker supports the managed pipelines, so do you have any great?
Yeah, we're gonna have to see. We haven't been following that work too closely, but we've been to the presentations about it here. I think that there's probably some smart ways we can integrate our work with that and create something bigger than either one. Use it as an amplifier for managed pipelines or something like that.
Yeah.
TBD. We need to figure out exactly what we're going to do there. But it's cool that obviously a bunch of the talks I've been to, every company kind of, maybe not to this extent, but to some extent made their own tooling to manage pipelines, whether it's from to convert Kubernetes manifests to pipelines or whatever. So we'll have to see how those integrate, but we definitely like to do that. Yes, sir.
We use Jenkins shared pipeline library in Wells Fargo heavily.
I'm sorry, I can't hear.
We use Jenkins shared pipeline library quite heavily, so I'm a bit interested in your experience. What I wanted to know is how does parallelism and checkpoint work? Because we've had some limiting cases in terms of what either counties or the DSL supports in those cases, especially around resumability.
We're not doing anything with Jenkins pipeline in this case, actually.
He uses a shared library, but in terms of like two steps, kind of running it in parallel, or
Yes.
From Spinnaker?
no, from within Jenkins.
Oh,
Yeah, so you're saying like there may be some concurrency issues, like where you have a step that happens and then they're both happening at the same time.
Oh.
Yeah, we tend to lock down a lot of those to just like have not execute concurrently, especially on some of those jobs. Yeah, like audit approval is another one of them. But yeah, I think we'd love to talk about that more at lunch. It sounds like an interesting topic because we have run into some of those challenges as well.
Any other questions?
Everyone wants lunch.
Yeah. Thanks so much for
All right, thank you, everybody.
We appreciate it.
Find us at lunch, or maybe we'll do a breakout session later if anyone wants to talk. So, thanks.
You know, stop.